Okay, we're going to be working in lesson 2.1 and 2.2. We're going to be solving one-step and two-step equations. So the first vocabulary word we see here is equivalent equations, okay? And so equations, we know that's something with an equal sign. Equivalent just means they're equal. All right, so equations that have the same value. Okay. All right, so now we're going to look at the first example here. And when we're solving equations, I sometimes like to draw a wall on it, and it just reminds us what we do to one side, we're going to do to the other. So remember, we are isolating that x. We want to get the x all by itself. So to do that, you've got to undo whatever's on the same side of it. So since this is plus 13, we are going to subtract 13 from both sides. So those will cancel each other out. We have an x left on this side. And then on the right-hand side, we're going to do negative 27 and negative 13, same sign, so we add them. So we're going to end up with negative 40. All right, going to the next example here. Okay, same thing. Just draw your wall. I don't care what side the variable is on. It doesn't matter. You are going to isolate. Oops, wrong one. You're going to isolate that guy. So you're going to get that guy all by himself. So to undo this negative 3 right here, we're going to do the opposite of it, and we're going to add 3 to both sides. So those cancel. Negative 7 plus 3, different signs we subtract, and we end up with negative 4. Now, you can check these to make sure you're doing it right. And so just keep in mind that a check would look like this. You're going to take it and you just plug it back in. So negative 7 equals negative 4 minus 3. And then you see, does it work? And think, yep, this works. So then you've got the right answer. So you can actually check all of these to make sure that you're getting them correct. Okay, example C. So same thing, but now we're going to be dealing with the fractions. So I'm going to put my wall up. We're going to isolate this y. And so to isolate it, we are going to add 2/3 to both sides. Okay? So now once I do that, those cancel. I have the y left here. And then yes, you're probably going to have to do a little scratch work here off to the side, and that's okay. You're going to have 1/2 plus 2/3. Since we're adding fractions, we need a common denominator. So our common denominator here would be 6. So now I'm going to multiply this guy by 3 to get to 6. And I'm going to multiply this side by 2. So I end up with 3/6 plus 4/6. So now we're just going to add straight across there and get 7/6. Now remember, you can leave it improper. So your answer here would be 7/6. All right, example D. Okay, so remember, we are undoing things. So now why we don't write it, there is a multiplication sign right there in the middle of that 4 times x. Okay, so we are going to divide. We're doing the opposite. So if it says times 4, we're going to, times 4, we're going to divide by 4. So we're going to divide both sides by 4. The 4's will cancel. Again, I'm going to draw my wall here. Okay, so I have an x that drops down because, again, we are isolating that x. We want to get that x all by itself. And then once again, I'm going to have to do a little scratch work here off to the side. So I'm going to have 4 divided into 4.6, so it goes in 1 time. So 0, now I'm going to drop in my 6. It goes in 1 time. Again, bring that decimal up. So I get 2. Now drop in a 0, bring it down. And you get 20. So 4 goes into 20 5 times. Okay? So then my answer here, a negative by a positive would be a negative, and then 1.15. All right, so it's going to be the exact same thing here, right? We're dividing because this says multiply. So we're going to divide both sides by negative 15. So those cancel. Again, I'm isolating that x, or that h in this case. I'm going to isolate that h. So I have an h left over here. And then over on this side, I'm going to take the 60 divided by 15. I'm going to get 4 when I do that. And then a negative by a negative is a positive. So there's your answer. All right, example F. So now this guy says divide. That's what that fraction bar means, right? Divide. So we're going to do the opposite or undo division with multiplication. So I'm going to multiply both sides by -9. Now the 9's will cancel. Again, draw that wall if you need to. You've got c left on the left-hand side. On the right-hand side, you've got 8 times -9, which is -72. All right, so now on this one's a little bit trickier. So a lot of you guys would say, well, it's times, so we're going to divide both sides by 4/5. And we started talking about this in last chapter, that this is called a complex fraction, and that it didn't matter if you wrote it, it didn't matter if you wrote it as 28 divided by, as a fraction, or you could write it out side by side. And then we know that division of fraction means that we're going to multiply by the reciprocal, okay? So now with that thought in mind right here, dividing and multiplying by the reciprocal, let's go back over here. So what you're going to hear me say in class a lot is that when we have a fraction times m, I'm just going to go straight to multiplying by the reciprocal. Instead of writing all this out and then flipping it, I'm going to go ahead and know that I just need to flip it right away, and I'm going to multiply by 5/4 on both sides. So I'm not really going to do this step right here, okay? So now when I do that, the 5's cancel, the 4's cancel, it all goes to 1s. So really I just have an m left on the left-hand side of the wall. And then over here on the right-hand side, I'm going to go ahead and work this fraction. Now I know that 4 goes into 28 7 times, and 4 goes into 4 once. So really I'm just multiplying straight across and getting 7 times 5, which is 35. Okay, so just to recap on this one. So if you think you want to divide by a fraction, go ahead and let's skip that step, because that just is no fun making it complex. And let's go ahead and just multiply both sides by the reciprocal. Okay, so now on this one, again, you're going to isolate your variable, right? We got to get that r all by itself. So we would divide by 7. It's the exact same thing as the other side almost. We divide by 7. So again, I can do that, or I can go ahead and multiply by the reciprocal and skip that whole division step. So that 7's will cancel on this left-hand side. We have an r equals. And then over here on the right-hand side, the 7 will go to a 1, 7 goes to 1, and then I'm going to multiply across 1 times 1 and 2 times 1. A negative times a positive is a negative. So I end up with -1/2. Okay, all right, let's go to the next page. All right, so now let's take a quick look at two-step equations. Okay, so the first thing we're going to do on a two-step equation is we're going to add that 6. Move the 6 over to the other side. Okay, so I have a 2a left on this side, and on the right-hand side I have left 10. Okay, so now we're back to the one-stepper, so I'm going to divide both sides by 2 since this says times in here in the middle, and I'm going to get a equals 5. Again, if you want to check it, you can do that by taking this and just plugging it in right there. So 2 times 5 minus 6 should equal 4. Well, that works out because 2 times 5 is 10 minus 6, and we know that that equals 4, so our answer is good. All right, I want you to go ahead and pause the video and try B on your own. Okay, so what you should have done here, again, you don't have to draw the wall, but I'm going to. You should have started by adding the 4 since it says -4. You're going to undo it with addition. You get 11x equals 33. Now, since that says 11 times x, you're going to divide by x. So you should have got x equals 3 as your final answer. All right, okay, so this is what I call a big fraction, okay? So let's kind of zoom out here. This little guy right here, he's a big guy. Big fraction bar, he's a big one. This is a little bitty guy. He's super small and skinny, okay? All right, so now the big dude, okay? We've got to take out the 8 first when we have a big guy. All right, so we're going to multiply both sides by 8 because this is saying divide, okay? And then we're going to multiply by 8 over here. Now, this case, the top is still there. It's still in play. The top is just going to drop straight down, okay? So don't do anything with it. Don't try to multiply everything by 8 or anything because these guys will cancel each other out. So I'm going to have a plus 7, top drops, equals 40. 8 times 5. Now, since it's a plus 7, I'm going to subtract 7 from both sides and get A equals 33. And there's your answer. Okay, so I want you to go ahead and pause the video and try D on your own. Okay, so you should have multiplied both sides by -2 again when he's the big dude. All right, when we got the big fraction here, we got to take out that bottom part first. So again, top should have dropped. So you'll have n plus 1 because the -2's cancel equals -30. And then you're going to subtract 1 from both sides. So I'm going to get n equals -31. Okay, and again, I know that because these are same signs, so we add them up. All right, next example here, example E. Okay, so now this is what I called the little guy, right? He's a skinny little fraction. When he's little, we take care of the buddy first because he's just a little guy. We're not scared of him. So we're going to go ahead, draw your wall, and I'm going to subtract the 2 off first so that those cancel out. So right now I have -3 and -2, which is going to give me a -5. And then on the right-hand side there, I still have the A divided by 11. Now to undo the division of 11, I'm going to multiply both sides by 11. So I'm going to end up with -55 equals A. And there's your answer. All right, I want you to pause the video and see what you can do with F here on your own. Okay, so again, when we have the skinny guy, right? Skinny guy, we take care of the buddy first. So we're going to add 8 to both sides. So we get 3/2 R equals 19. Now in this case, again, we talked about that you could divide by 3/2 and then multiply by the reciprocal. Or we talked about you can go ahead and just go straight to multiplying by 2/3 on both sides and not worrying about this bottom part, okay? So now when you do that, the 2's and the 3's on this left-hand side all cancel and go to 1's. So I only have an R left over on this side. And then on this guy over here, I've got 19 times 2/3. Now, I can put that over 1. Nothing is going to cross cancel there, so we're just going to multiply straight across. So 19 times 2 is 38. 1 times 3 is 3. And there's your answer. Okay. All right, word problem time. Okay, so here is going to be our expectation on word problems. Okay, we are going to expect you to define a variable. So there's going to be something unknown in here, and we expect you to define the variable. Again, just look at the question. Okay, so whatever the question is, we're just going to restate it. We're going to write an equation, we're going to solve it, and then what we're going to do is we're going to take our answer and we're going to interpret it using a complete sentence. So in other words, what does it really mean? What's going on in the problem? So toucans and blue and yellow macaws are both tropical birds. The length of an average toucan is about 2/3 of the length of an average blue and white macaw. Toucans are about 24 inches long. What is the length of an average blue and yellow macaw? All right, so again, define your variable. That's step 1. Okay, so we are looking for the length of I'm just going to say macaw instead of putting the blue and yellow in front there. Okay. All right, so, and when I do this, a lot of times I like to make it letters that kind of applies to what's going on in the problem so it doesn't confuse me. So I'm going to put M, length of, macaw. Okay, now sometimes it's just a matter of breaking down the words. Okay, so now if I kind of come up here, I'm going to highlight a little bit for you here. So the length of a toucan is, that's an important word, 2/3 of the length of a macaw. Okay, so now let's kind of break down those words. What do we know about a toucan? Well, right here, we know that toucan is 24 inches long. Okay, so remember how we broke down words in the last chapter? We're going to do the same thing here. Length of the average toucan. So toucan, what do I know about toucans? They're 24 inches long. What does the word is mean? Is means equals. So as I'm starting to write my equation here, I'm going to do 24 equals, now let's see what's on the other side here. It says 2/3 of, think about what of means, that means times, so 2/3 of a macaw, or in this case, a macaw is going to be m. So we're going to do 2/3 m, okay? All right, so now we're going to multiply by the reciprocal, okay? So we're going to multiply by 3/2 on both sides, so that all goes to ones. Okay, now over here, we put that over 1. I'm going to cross cancel. So the 2 will go to a 1, the 24 will go to 12. So now I'm just multiplying. 3 times 12 is 36 equals m. Okay, because again, we're isolating, right? We're trying to get that m all by itself. Okay, so now with that being said, we need to interpret your solution, okay? So we're looking for the length of a macaw, so that's what we're going to talk about. And what's our unit of measure? Inches. Okay, so we're going to say the macaw, is it O? Nope, it's an A, is 36 inches long. Okay, period. So that's what we're looking for when we ask you to write a complete sentence. Okay, all right, go to the next page. All right, and our last problem here that we're going to do is we have a pizza shop charges $9 for a large cheese pizza. Additional toppings cost $1.25 per topping. Heather paid $15.25 for her large pizza. How many toppings did she order? All right, so let's go ahead and start by defining our variable. So we're looking for how many toppings, because that's what our question is. So I'm going to put T for a number of toppings. Now, don't just say toppings. Make sure you're specific. Are we talking about how many pounds, what type? Like, what are we talking about here? In this case, we're talking about how many there are. Okay? All right, so now it says it charges $9 for a large pizza. So large cheese is $9 no matter what. Additional toppings, so think about what additional means. Toppings cost $1.25 per topping. So when I start kind of writing this out here, it's $9 for the pizza. Then it's $1.25 for each topping, which is just T for right now because we don't know how many toppings we've got. And then they gave us a total. They told us that she paid $15.25 for her pizza. So $15.25 is her total. Okay? All right, so now we're going to do a little solving here. So we're going to start by subtracting the 9 off from both sides. So that cancels. We get $1.25 T equals $6.25. And then when you divide by $1.25 or 1.25, you will find that you end up with 5 toppings. Okay, so now again, we're going to write our sentence. So off to the side here, I'm going to write a sentence here. So there were 5 toppings on her pizza. Okay. All right, that concludes the notes for lesson 2.1 and 2.2.